In the last section, we found that many real-life situations can be represented using linear models. In this section, we're actually going to figure out how to find equations of these linear models. We're going to focus on two different situations. One where the data is described vertically, and then we're also going to look at how to do the same problem when the data is given in tables. We'll start with the situations that are described verbally. In this example, we can see the number of high school students who took the military's aptitude test has decreased approximately linearly from 857.6 thousand students in 1999 to 539.3 thousand in 2007. We'd like to find the equation of a linear model to represent this situation. Now, before we can do that, we have to define our variables. We're going to let t represent the number of years after 1990, and this will be the independent variable, or like our x variable. And we'll let n represent the number in thousands of high school students who took the military's aptitude test. This will be our dependent variable, which will be treated like a y value. The key thing to realize is that the given information actually gives us two ordered pairs. First, we're told that there's 857.6 thousand students in 1999. Now that means in the year 1999, which corresponds to t equals 9, since it's 9 years after 1990, the number that took the test was 857.6 thousand. Also, we know that the number was 539.3 thousand in the year 2007. Now 2007 would be a t value of 17, since that's 17 years after 1990, which is the reference point in this problem, and then the number was 539.3 in thousands. So basically, all we need to do is find the equation of a line that passes through these 2 points, which we've already learned to do in a previous section. The first step would be to calculate the slope between these 2 points. We just use our usual slope formula of y2 minus y1 divided by x2 minus x1. And in this case, since this is an application, we want to get a decimal answer for that, so we'll just divide that right out all the way in our calculator, and it comes out to be negative 39.79. Now we just need to choose one of the two original ordered pairs to use along with this slope. I'll pick the first one, 9, 857.6. Now we can use point slope form, which remember is y minus y1 equals m times the quantity x minus x1. And if we substitute the values in for m and x1 and y1, we end up with y minus 857.6 equals negative 39.79 times x minus 9. And we just want to simplify this, so we're going to distribute out the right side as we normally do. So we'll get y minus 857.6 equals negative 39.79x. It's a negative times a negative, so it'll be plus 358.11. And then if we add 857.6 to both sides so that we can solve for y, we will get our equation of our line, which is y equals negative 39.79x plus 1215.71. Now remember, in this problem, since this is an application, we're not really using x and y. in place of the x, there's really a t right here. And in place of the y, there'd be an n, which is our dependent variable right here. So I'm just going to rewrite this equation using the variables n and t instead of y and x. So we'd have n equals negative 39.79 times t plus 1215.71. And this would be our linear model. Now the nice thing about having an equation of a linear model like this is you can use it to make predictions. For example, let's say we wanted to predict the number of high school students who take the military aptitude test in the year 2010. Now remember, t represents the number of years after 1990. So the year 2010 really corresponds to t equaling 20, since that's 20 years after 1990. So all we'll do is substitute a 20 into our model in place of where the t is. So we will then end up with n equals negative 39.79 times 20 plus 1215.71. And when we work this out, the answer comes out to be 419.91. And remember, this is measured in thousands, so that would be that many thousands high school students. Next, we're going to investigate how do we make a linear model for a set of data given in a table. And the first step for that is to make a graph that's called a scattergram. And I'm going to show you how you can do that on your calculator, because although you can do that on a piece of graph paper, it's really a lot easier if you can learn your calculator how to make this sort of graph. The first step would be to define our variables. And we're going to let t represent the number of years after 1980. T will be our independent variable, and that'll be treated just like an x variable. We're going to let L be the life expectancy in years. L will be the dependent variable and will be treated like a y variable. Now the first step is to enter this data into our calculator. And to do this, we are going to use the stat key. So we'll press the stat key, and then you can see the command edit is highlighted, which is option 1. So we'll hit enter on that. And it brings up a series of lists. Now the first thing to do is delete the entries out of a list from an old set of data that you might have been working on. So you highlight the name of the list, L1, and then press the clear button. And then when you go back down with your down arrow into the list, the entire list will clear out. And you would do the same for L2 if needed. You can also just delete each entry one by one if you want, but it's faster to delete the entire column. And at this point, we just want to start entering the values in. Now remember, 1980 really would be a 0, because that's 0 years after 1980. And 85 would be a 5, and 1990 would be 10, and then 15, and then 20, and 25, and then 26. So those are the values that are put into L1. You always put your x values into L1, or your independent variables. And your dependent variables, or your y values, always go in L2. So we'll just enter those numbers in, 73.7, and then right on down the list. Okay, so you just put your x's into L1, which is our time values, and our y's into L2, which are the life expectancy values. Okay, and I'm down to the last piece of data, 78.1. And so once you get all your data in there, you now want to set up the graph. So to do that, you hit second, the blue button, and then the y equals key, which is stat plot. And under plot 1, you see that it's turned off. We want to hit enter on plot 1 so that we can turn it on first of all. So you have to hit enter again to turn it on. Okay, so it should be blinking on. The type should be set to the one that kind of looks like a scatter plot with the points scattered around. For X list and Y list, it should say L1 and L2. And the mark can really be anything. I like to use the square one because they show up nice and big. And then once you've got that all set up, you do zoom. And it's going to be number 9, which if you scroll down your list, you'll see zoom 9 is a zoom stat. This will automatically make the picture come out looking nice. So it's option number 9, which you can either just hit the 9 key or highlight it first and then hit enter, either way. And then you'll see the scatter plot comes up on the screen. Now I'd like to show you how you can find the equation of a linear model by using 2 points. So the key idea here is we're going to pick 2 points and then find the equation of the line that passes through those 2 points, which we already know how to do. So we want to try to select 2 points on the graph that will give us a line that closely matches up with the data points. And a lot of times we can pick 2 of the actual data points, but you don't have to use data points. You could use a point that's not one of the data points if necessary. But in this case, I'm going to use the very first ordered pair, which is 0,73.7, and on the graph that shows up as this point right here. And then I'm going to use the very last ordered pair, 26 and 78.1, which is this one way at the end here. Now to me it looks like if I connect those 2 blue points with a straight line, that would give me a pretty good linear model for this set of data. Now you don't always have to use the first and the last point. Use whatever 2 points would give you the best model. And if you can't find any pair of points that gives you a good model, then sometimes, like I said, you'll even have to use a point that's not one of the data points to do this. But usually we try to use 2 of the data points if possible because it's just easier to work with and we already know what their ordered pairs are. So I'm going to use those 2 ordered pairs, and now my job is to find the equation of the line that passes through those 2 points. Okay, so from here we do it the same as we've learned before. We first find the slope, so we'll do m equals 78.1 minus 73.7 divided by 26 minus 0, and we'll work out that answer. And again, we'd like to write that down as a decimal here, and I'm going to round that off to 0.169. Then I have to pick one of the 2 original points to use with that slope. I'll use the first one because the 0 in the x-coordinate will make that simple to work with. And so I'm going to use point slope form now. So y minus 73.7 equals 0.169 times x minus 0. Of course, x minus 0 is just x. And so that gives us y minus 73.7 equals 0.169x. And then when we add 73.7 to both sides, we will get our model. Y equals 0.169x plus 73.7. And again, the letters that we're using are x and y. Instead of x, we're going to use a t because that's what we're letting to represent time. And instead of y, we're going to use L because that stands for the life expectancy. So we should actually write our answer down using those 2 variables as our final answer. So we'll get L equals 0.169 times t plus 73.7. Now we'll use our graphing calculator to graph the linear model through the scattergram and also to check that the two given order pairs do lie on that line. So we'll start by pressing y equals, and we'll type in the equation of our model, 0.169. We have to use an x on our calculator, we can't use t, plus 73.7. So we'll go ahead and enter that equation in, and then we'll just hit graph. And it should graph that model right up through the scattergram. And now to check that the two given order pairs that we used to create this line are on there, we'll do second trace, and then we'll use the value command, number 1, which is the very top one. And we'll just enter in the x coordinate that we want to use. We're going to use 0 for this first point. And when we hit enter, it should give us the 73.7, which you see it does. That confirms that that point is on the line, and you can see it's blinking at that point. We'll do the same for the other, second trace. We'll enter in the x coordinate, 26, hit enter, and you can see the y coordinate rounds off to 78.1, which matches up with ours. And again, you can see that the cursor is blinking at that last point on the graph. So that checks. Now there's also another way of finding a linear model through a scattergram that involves statistics, and it's a little bit more scientific way of trying to find a linear model which most closely passes through a set of data points. And when you do it this way, it's called a regression line. And I'm not going to go through the details of how to actually get a regression line by hand. You might look at that in a statistics course. But I'm just going to show you how you can use your calculator to easily find this regression line. Now you would start the same as we did before by entering all the data points into your calculator and making a scattergram on your calculator. Once you've done this, you'll go ahead and use your calculator. You'll hit the stat key, and then you want to go over to where it says calculations, and you use your right hand arrow to move it to that point, and then scroll down here to where it says linear regression ax plus b and hit enter. And it should show up on your screen that way, so you have to hit enter a second time to get the results to come up. And you see it says y equals ax plus b, and then it gives you a and b below. So you have to put that all together to write down the equation of your line. So we would have y equals, and then we plug a in. I'm going to round that off to 0.165. 0.165 x plus b, and again we'll plug b in, 73.7. And this would be the regression line. And that should also be a very good model for this set of data. Now if we press y equals on our graphing calculator and enter that equation in, 0.165x plus 73.7, and then hit the graph key, just like we did before, it'll show that line. And you can see that again, that does represent a very good model for this set of data. Now I think it's interesting that the regression line, which uses a complicated statistical technique, came out so close to the one that we did by just picking 2 points on the graph. The one that we got using 2 points, remember, was y equals 0.169x plus 73.7. So this is the one we got using 2 points. We used the first and the last ordered pair. And if you compare these, Notice that the y-intercepts 73.7 match perfectly, which is really good. And the slopes, or the numbers in front of the x, the regression line slope is 0.165, and the slope we got using 2 points is 0.169. Again, those are very close to one another. So both of these are good models. And now you know two different ways of finding a linear model for a set of points given by a table. And I'll always be clear on a test to indicate which of those two ways I want you to use. So just be sure that you can do it both ways. And if I want you to use the regression line, I will definitely say to find the regression line. And if I want you to use 2 points, then I'll say that in the instructions, so you'll know which way to do it.